Tautology. Statements which are always true are called as tautologies. For example, consider the following statements. A number is either an even number or an odd number. This statement is a tautology because this statement is always true. You take any number, that number will either fall into the category of even numbers or into the category of odd numbers. That's why we say this statement is always true and hence it is a tautology. The weather was hot and it was scorching outside. This statement is also a tautology because it is always true. Whenever the weather is hot, it will be scorching outside. That's why this statement is always true and hence it is a tautology. It was a free gift that cost nothing at all. This statement is also a tautology because it is always true. You take any gift which is free, it costs nothing. That's why we say this statement is always true and hence it is a tautology. She always arrived on time and punctual. This statement is also a tautology because it is always true. Because this lady always arrives on time. That's why we say she is punctual. That's why this statement is always true and hence it is a tautology. Now let us look at the definition of tautology. A proposition that is always true is called a tautology. Let us consider an example. Verify whether the proposition P disjunction negation P is a tautology or not. To solve this problem, you need to remember P disjunction Q truth table. You see, in P disjunction Q, it is false only when both P and Q are false. In every other case, P disjunction Q is always true. Now let's look at the truth table of the given proposition. P negation P, P disjunction negation P. If P is true, then negation P will be false and P disjunction negation P will be true. If P is false, then negation P will be true and final result will be true. You can observe that the logical formula P disjunction negation P is always true, regardless of the truth values of the propositional variables it contains. Hence, the proposition P disjunction negation P is a tautology. Let's consider one more example. Verify whether the proposition negation of P disjunction Q is a tautology or not. For this also, you need to remember the truth table of P disjunction Q. Please observe that P disjunction Q is false only when both P and Q are false. In every other case, P disjunction Q is true. Now let's look at the truth table for the given proposition. P, Q, P disjunction Q and negation P disjunction Q. If P is true, Q is true, then P disjunction Q will be true and its negation will be false. If P is true, Q is false, then P disjunction Q will be true, then its negation will be false. If P is false, Q is true, then P disjunction Q will be true, then its negation will be false. If P is false, Q is false, then P disjunction Q will be false, then its negation will be true. All the values in the column negation P disjunction Q are not true. Hence the given proposition is not a tautology.